Welcome back to the 42nd part of Debugging at Scale, where networking leaves all the details we need to solve the problems. In the third module, we discussed Wireshark, which is an amazing tool for observing networking traffic. The tools within the browser exceed it for most common use cases and make debugging network performance and bugs stupid simple. Many problems express themselves in the front end either via the console or the network monitor. I'll skip the discussion of performance since that is a subject so big it warrants its own book. In this case, I want to highlight tricks for debugging using these network consoles. The Firefox Network Monitor, seen here, is very similar conceptually to the Chrome Network Monitor here. Both include nearly identical functionality and capabilities. Due to that, I won't demonstrate most functionality in both browsers. One of the biggest capabilities is the ability to reissue a request. This is far more convenient than pulling out curl or postman, since it allows us to modify an existing network operation and change some arguments. Firefox lets us right-click over any entry in the network monitor and select Resend to launch an edit window. We can now issue a custom request and change the parameters we pass to the request as shown here. Both Firefox and Chrome support copying the request as a curl command. You can find that capability under the copy menu in the right click. This lets us reproduce an issue from the command line without going through the browser. You can also copy request headers and paste them into Postman headers section if you prefer working with it. One of the most useful features in the network toolchain is the throttling feature seen here. With it, we can slow down the request speed to various predetermined speeds. This is wonderful for debugging performance-related issues, but it's also an important tool in debugging race conditions and problems that only occur in slower connections. One of the biggest problems in debugging an application is misbehavior specific to a device. This is often caused by local storage on the device that stores local cache or related information. A common workaround among front-end developers is the usage of incognito mode, also known as private browsing. However, this approach has a few drawbacks. State is shared between incognito windows. If you accidentally leave a private session open in one window and open another, the state will be kept and it would be hard to notice. We might want to keep some state for convenience. Both Chrome and Firefox include great support for managing storage in their respective developer tools. Firefox has a dedicated storage tab that you can see here. Chrome includes everything in its application tab, as you can see here. The storage area lets us push debug information into storage to test specific edge cases. An end user can provide us with local state from their browser, which we can add locally. We can remove and edit individual elements from all storage types, including cache. Networking and storage are the perfect transition points to the other end, the database. In the next video, we'll discuss debugging the database layer to create that tongue motion that we want. If you have any questions, please use the Slack channel to ask them. Thank you.